Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, it's nearly Happy Aloha Friday. Happy Thursday to you, and I have a load of stuff to consider. First, good news. It happened again 2 weeks ago. We were supposed to have this kind of like smallish storm roll through the high country, and instead it brought several feet of snow to the high country. And it was just supposed to bring a little bit. And then the last couple of days, the last 48 hours, another smallish storm predicted for the high country down here too. We didn't get much rain, but the high country has ended up, it looks like, in many places getting over a foot of snow. So it happened again. So I'm going to call it a God thing and just answer to prayer. And we're going to keep praying for, you know what I'm praying for? I've already told you. I am praying for a 3-footer. A storm that'll dump 3 feet across the high country. I just think, boy, that would give us a bunch of water. So anyway, so bring it on, Lord, bring it on, we pray. And help us to fill up our lakes. So, and thank you for what you have already brought. That's our drinking water up there in the form of snow. That's our drinking water. That's what it is. And the water that we use for everything else, which is like everything, you know. And that's water that's going to end up in you, and you're 70% water. So don't just blow it off and go, oh, who cares about that snow? We don't care. It's kind of important. Yes, indeedy do. So anyway, we're thankful for all that snow, and like I say, I am praying for a doozy of a snowstorm. That would be the 3-footer. Doozy, I say, one of my favorite adjectives. So you should incorporate it into your adjective vocabulary. Doozy. That means over the top, amazing. So anyway, pretty cool. So, and then I just want to remind you about SSRs. Remember, anytime over the next 8 weeks or so, turn in your 10 SSRs. Do a nice job on them, though. Neat, complete. Okay, 10 points. It's not an option. You got to do it. So, in it goes. Can't use a homework pass on this. Nope, can't use a homework pass. So, everyone's got to turn it in. I want to see some SSRs from you. I want to force you to come up with some SSRs that you can thank God for, that He gave you, that you can go, thank you, Lord. Remember, He customizes SSRs for us. I got 2 customized, probably some more that I haven't even noticed, but I got 2 customized ones today. So when we were driving over on the freeway near Sky Harbor Airport today, lined up with us was a Delta 777, one of my favorite airplanes, and I look up and it flies right over our head. I love the color scheme of Delta Airlines, and that is one big, long airplane. It might have the most powerful, 2 of the most powerful individual jet engines on an airplane right now. The C-5 military airplane probably, has ones that are as big. Maybe, but the 777, amazing. We've flown down to Australia on 777s many times and back from Sydney. And speaking of Sydney, thank you for praying. The flood waters are going down. The rain has abated. Another vocab word for you, has stopped. So, and I'm going to pray it's going to continue to stop. So I appreciate you praying for my daughter Lisa down in Oz. So now, you're going to work with your journals, of course, today. So, and I'm just going to say this. I got some intel today. Intel is like, it's like when a CIA agent gets some information that's useful. Well, I got some useful intel today. And you know what it was? That yesterday during the video, most of you, here was the intel, most of you put down bullet facts. Good on you, as they say down under. But here was the intel that was interesting. There were a few of you, I'm told, who didn't put down any bullet facts. Oh my, what will happen? Remember when I look at your journals toward the end of the year and I flip to those pages where you're supposed to have bullet facts about the Higgs boson particle and the Higgs field, and I don't see any. That'll be -10. Oh no, when the journal information is maybe only going to be 30 or 40 anyway. Oh no, that'll be a huge deduction. So it's up to you. Good decisions, bad decisions. People make good decisions and bad decisions. So, anywho, my advice to you would be today in your journal, make sure you're working with it. And when I tell you I will look for this in your journal, I would stick it in there. So some of you will come down to the end of the year and you'll need 30 points. You'll need it. You know, it'll be maybe even 40. And you'll be hunting for 40 points. And I will have collected your journals and I will go through them and I will assign you a maximum number of points. Excellent job, 40 out of 40 perhaps. There'll be many of you, that's what you'll get. Some of you will do, kind of, so-so job. You'll get a 75. You'll get 30 out of 40, that's 75%. There'll be some of you that will have, half of what you should have. You'll get a 60%, that's a D minus. And I hope not. I hope there's no one in this category. But just didn't put anything in there, didn't really work with it. 0. So it's like flunking a test. 0 out of 40 on a test. Ooh, that would not be good. No, not good. So I'm saying good decisions. Good decisions today. Mr. Phillip will give me a report from each class. Hey, how'd they do on sticking bullet fact information in their journal when I said this should go in your journal? How'd they do? I'll get a report. I'll find out. So, anywho. Now, technically speaking, no test or quiz tomorrow. What do you mean, technically speaking? I'm not telling. Technically speaking, no test or quiz tomorrow. Mr. C, are you giving us a Pinocchio? No, I am not. Is there a scheduled test or quiz tomorrow? Nope. Are you going to give us an official quiz or test tomorrow? Nope. Nope. A scheduled test? Nope. So, that's all I'm saying. Wink, wink. Kind of mysterious, isn't it? Yeah, it's a lot like all that we've been doing this week in science on physics. Yeah, mysterious. I love that adjective. Mysterious. Hey, I just wanted to tell you really quick on the SSRs. The other customized SSR I got today was, I love this time of year because of the citrus smell. I love the citrus smell. So, Mr. C, could we use that as one of our SSRs? I love the citrus blossom smell as well. Sure, you betcha. I'll let you use that one. But as I'm doing my walks around my daughter's neighborhood, oh man, I love the orange and lemon and grapefruit flower blossom smell. It is so cool. Okay, I'm looking over everything. I'm making sure I got it. So just going to say one last thing. Return to the snow in the high country. Some places I checked today just to see how much snow had fallen in the last 48 hours. Some places up to a foot, like I say. So anyway, White Mountains up north. I hope there was some good snow on the Verde River watershed, which is really low. The Verde River lakes are way down. So anyway, we shall see. All right, journals are out. I'm going to have you put some things in your journal. And at the same time, I'm going to tell you about next week. It's at the 10-minute mark right now. I'm not going to take a break at the moment just because we haven't really done anything that is deserving of a break right now. So Mr. Phillip will, during the video, stop it right in the middle, and then you can get caught up a little bit on bullet facts that you're going to end up putting in your journal. But I want to tell you what I'm going to look for in your journal already. Both 7th and 8th grade, you should have down like the 6 elements from the periodic table of elements so far that we've gone over. You should have those. We've done the bookend ones that are the atmosphere, right? I'm sorry, the bookend atmosphere on the sun. Hydrogen and helium. Atomic number 1 for hydrogen, just 1 proton. That determines the atomic number. And 2 for helium. So 1 for hydrogen, 1 for helium. I'm sorry, 2 for helium. Okay? Number of protons, we've done those. We've done the 2 gases found in Earth's atmosphere. What would that be? N for nitrogen. Next week's Thursday test, this will be on there for both 7th and 8th. And then O2, oxygen, of course. And then we did Fe for iron, found in our soil and in Martian soil. And then we did the major element found in living tissues, C for carbon. Atomic number of 6 protons in the nucleus. So I'm going to ask you that. And then both 7th and 8th grade, I'm going to ask you for a diagram of an atom. What are atoms made of? They're made of electrons that orbit the center, kind of in a cloud. I'm going to ask you what the best model we can think of right now, or analogy for an atom. That would be a cloud. How many times have I told you that? Is that in your journal? Is all this in your journal? You got this in your journal? Everything I mentioned? Be there in your journal, or be square. Okay, and then in the nucleus, the center of the atom. This is a helium atom. 2 protons, 2 neutrons. Atomic number of 2. So what are the particles that are found in the nucleus of atoms? I'm going to ask you about how many different kinds of atoms are there on the periodic table. A little more than 100. Have you got that in your journal? I'll ask. And this is what you're going to review tonight. Triple R all of this tonight. Look it over. How much time? No more than 10 minutes. Look it over. Kind of an easy week for homework, yeah? But not an easy week for what I've had you pay attention to. And I'll get to that in just a little bit. So anyway, those are that is the diagram of an atom and what an atom is made of. Now, I made myself up a little sheet from this week, and here's where you're probably going to stick some new stuff in your journal. So let me have you, this is from this week's videos, okay? So this week's videos. Now I need to turn this ahead. Do I have this? I think so. Yeah, there it is. Okay. So from this week's videos, first, the very first video I showed you was on the chart of the different particles that everything is made of. What is that called? It's called the SM, or Standard Model. I'm going to ask you that next week. What is the chart called that lists the basic particles that everything is made of? SM, Standard Model. So then that leads to next, what is the name of the, or I'll say it this way, what does the LHC stand for? So stick that in your journal. LHC. What is that? LHC. I'll ask you this, all of this. It stands for Large Hadron Collider. Hadrons are particles. Now, I'll ask you this. Why is it called a collider? Easy. What are they doing with the Large Hadron Collider? They're smashing hadrons together. What kind in particular? Protons. It's a collider. It's an atom smasher. So I'll ask you, what does LHC stand for? Real basic. I'm not going to ask you, like really, really in-depth questions, but basics. Okay? So far we've got Standard Model for the list of basic kinds of particles, atomic particles. Standard Model. That's what physicists call it. Then the LHC, Large Hadron Collider. Why is it called a collider? Because protons are colliding at close to the speed of light. Next question. Put it in your journal. Mr. Phillips watching, are you sticking this in your journal? He's eyeballing things. And he'll give me, kind of a general idea of each class. How did they do? And specifically people who are just absolutely refusing to put anything in their journal. Yeah, I think a list would be in order at this point. He's got a seating chart. Yeah. LHC, Large Hadron Collider. And why do they smash protons into each other? To find out what the protons are made of. What are the smaller particles? What are they called? So, 3 questions on that LHC video. What does it stand for? Large Hadron Collider. What are hadrons? Protons. And there are other particles too that are hadrons. Why do they smash them into each other in the Large Hadron Collider? To find out what they're made of, the little, even smaller subatomic particles. That's why. Now, what are the 4 basic, so far that we have discovered, subatomic particles that can't be divided any further? Remember, they thought for a while the atom could be subdivided. Wrong. Okay, it can be, as you know. So, electrons. These are going to go in your journal. What topic should we have here? These are the basic particles that everything is made of. So these are the basic ones. The kind of like, what's the term for them? Universal particles. Okay, we've so far figured out electrons can't be subdivided. And then what are protons made of that we have discovered using colliders that can't be subdivided? What are they made of? They're made of quarks. Quarks. Don't you love that? Quarks. So quarks. And then in your journal, so we've got electrons, can't be subdivided. Quarks, can't be subdivided. Okay? Well, except into different kinds of quarks, but they're still quarks. Okay? As you see, that's giving me a headache. All this week you've given me headaches with this really complex stuff. I have a purpose for that, which I'll reiterate in just a minute. Okay? So electrons, quarks, and then in your journal, what are the particles that come off the sun that are traveling at the speed of light? They're incredibly tiny, and they pass right through us by the trillions all the time. Woo, 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 woo. There they go. You can't feel them. I'm just being silly. Woo, there goes another one. Neutrinos. Woo, neutrinos. Can't feel them. Do they tickle? No. We don't. We're not aware of them. Do they hurt us or damage us? Nope. As far as we know, they don't. Woo! There goes another neutrino. Well, there goes another trillion neutrinos. Okay? So electrons, quarks, neutrinos off of the sun, and then the fourth particle you just learned about yesterday, the Hb or Higgs boson. Higgs boson. Got to be in your journal. These four fundamental particles. Can't be subdivided. Electrons. I'm doing this on purpose. Mr. C, you've gone over these. I know. I want to make sure you've got them in there in your journal. Electrons. Quarks make up protons. And then neutrinos. And then Higgs bosons. Haven't discovered any new particles since the Higgs boson in 2012. They're looking, but they haven't found anything else. So, and how are we doing time-wise? Good, good, good. I wanted to show you this. And I'm going to tell you how to remember this. Okay, it's one of the ways that atoms are held together. You know, it says in Colossians, I read that to you this week, in Jesus, everything holds together. That would include atoms. So here's the way an atom holds together. Okay? These are protons, or a proton and neutron. Now you heard this already, so draw this in your journal, little sketch, just a round circle. Put plus, that's for proton, and then underneath you can put proton, which are made of quarks, right? So protons are made of 2 up quarks, that's why I have 2 U's and 1 D for a down quark. So UU and D, protons. 2 up quarks and 1 down quark. Mr. C, why? I'm going to explain in a minute. And then look at the plus minus particle, see it? That's a neutron. And neutrons are made, you know how you're going to remember? How many U's are in neutron? Neutron. How many U's in neutron? 1. So 1 up quark for that U and 2 down quarks. And this right there, that neutron. See, that's plus, move over, plus minus. That's a neutron. Neutral electrical charge. Okay, I'll leave it there for a minute. The proton, quark, and then the neutron. Remember, how are you going to remember? The neutron just has 1 up quark and 2 down quarks. I want you to know that. Just kind of fun to know that. Folks, I'm turning you into physicists, particle physicists. Isn't this stuff mysterious and fun? I love this stuff. I mean, it's just so interesting. And it brings God so much glory because it's so complex. Now, I was going to read to you, and I don't even have time. I'll do it tomorrow. I was going to read to you a quote, kind of the latest quote, or 2 year ago quote, from someone writing about physicists. And physicists themselves admit. One physicist said, if someone says, oh yeah, we know everything there is to know about particle physics, Pinocchio, no they don't. There are so many mysteries that they don't understand. And the Higgs field, which I'll talk about tomorrow a bit, and have you put some things in your journal on the Higgs field and the Higgs boson. And then today in your journal, you're going to watch a little short 3-minute video on the 4 fundamental forces that are involved in the universe. And they all have a specific, unique value that can't change, or matter won't hold together. This is so, and it's fine-tuning, so fine-tuned our universe that it couldn't have randomly formed from the Big Bang, which was totally, according to their model, the Big Bang model, random. No one did it, accidentally happened, silliness, silliness, silliness. Folks, the data we're getting from these particle physicists, fine-tuning, and these 4 forces are fine-tuned, and you're about ready to see that. You already know about 2 of them. Actually, you know about 3 of them. You know about gravity. You know about electromagnetism. Opposite charges attract, like charges repel. So you've already got that. And you know about the strong force. So those 3 forces. So you're going to hear, and you're going to write in your journal about the 4 forces that pull and push things in our universe. And again, so much glory to the Lord. So get ready to write in your journal as you watch this video the 4 kinds of forces. Mr. Philip will stop it halfway through, let you get caught up, and then you'll see the rest of it. So, hey, enjoy this stuff. This is cool stuff. Okay, people will think you're cool if they hear you talk about the strong nuclear force that overcomes the repulsion force of protons in the nucleus. Jesus solved that problem. Anyway, take it away, Mr. Philip, on this 3-minute video.